Okay, so for lesson 6.2 for Math 9, we're going to focus on solving multi-step equations. Just reminders from the lesson before, equation just means something that has an equal sign in it. Solving means you're figuring out what the variable would equal to make the original question true. The terminology I like to use is get the variable. In this case, I'm just going to say x, so get the letter by itself. Lesson 6.1 is doing one-step equations to solve. Now we're going to do multiple-step equations. I'm going to show you some strategies that I like to use and how we handle this. Before we get going, there's a couple things that we need to remember. The first of which is BEDMAS. So BEDMAS is the order of operations in which you perform calculations. When you're solving, we're going to use BEDMAS, but we're going to go backwards. So we're going to start at subtraction and move the other way. So we're going to start with subtractions, additions, then multiplications, then divisions. And what we're going to do is we're going to move those things first. And you'll know what I mean when we get going. The other thing that we need to remember is something called opposite operations. Opposite operations, for instance, an operation is like addition. So the opposite operation of addition would be subtraction. To be able to solve or isolate something, we have to be able to do opposite operations and know what the opposites of things are. So the opposite of addition is subtraction. Opposite of subtraction is addition. The opposite of multiplication is division. The opposite of division is multiplication. Awesome. We're going to look at this first question. Question A. We need to solve the equation. That means get m by itself. To do this, we're going to work backwards with BEDMAS. So when we see our letter m, we're going to try to move the numbers away from m. We have 4 times m, and then we have a plus 3. According to BEDMAS, we want to remove any subtractions, which we don't have, and then any additions first. So in order to do this question properly, the first thing we have to move is that plus 3. The way we move something is by doing opposite operations. So the opposite of plus 3 would be minusing 3. Now, you'll see that I will always do something, in this case, move my 3, so I subtracted 3, and then I'll reorganize my work. I highly recommend you do that as well. So anytime you do a calculation, you should write it down like I just did, minus 3, and then reorganize. So on the left side of my equation, the only thing I have left now is 4m. On the right-hand side of my equation, 11 minus 3 is 8. So I did something, I reorganized, and then I move on to the next step. So if I'm doing BEDMAS backwards, the next thing I want to move is any multiplications. This is multiplication. So if there's nothing in between a number and a letter, that means multiply. So there's 4 times m. The opposite of times is divide. So we're going to divide both sides by 4. On the left-hand side, that will cancel out, and I'll be left with just m. On the right-hand side, 8 divided by 4 is 2. So my answer is m equals 2. Wonderful. If we look at b right next to it, we have the same situation. So we want to solve that equation. That means we want to get x by itself. To do that, I need to move any subtractions or additions first. There is a subtraction next to my x, so I have this subtract 14. The way we move something is by doing opposite operations. So I'm going to add 14 to both sides. Remember, what we do to one side, we do to the other. So when I add 14 to the left side, it cancels out. I'm going to reorganize my work. So I have 2x equals negative 8 plus 14 is plus 6. So I did something in red, and then I reorganized my work in black. The next thing I have to do is get rid of that 2. That means 2 times x. The opposite of timesing or multiplying is dividing. So I'm going to divide both sides by 2. Gives me my final answer of x equals 3. Wonderful. And those are pretty standard questions. Looking at C and D, we have something a little unique. We have brackets in these questions. The way that I like to tackle brackets is I like to get rid of the brackets. And the way we get rid of the brackets is by distributing into the brackets. So if we focus in on C here, I want to get rid of those brackets by taking whatever number's in front and multiplying that number into the brackets. So remember, that's distribution. We learned that in Unit 5, I believe. So I'm going to distribute that 5 into the brackets. 5 times n becomes 5n. 5 times 4 becomes plus 20. And it still equals 40. And now that I've gotten rid of the brackets, I can solve or focus on starting to solve. I want to get n by itself this time. So to get n by itself, I need to move the plus 20 first. So I'm going to subtract 20 from both sides. After I do something, I reorganize. So on the left side, I have 5n still. Equals 40 minus 20 is 20. Now I need to get rid of that 5. The opposite of 5 times n would be dividing. So I'm going to divide both sides by 5. That leaves me with n on the left side. 4 is my answer. N equals 4 is my solution. Wonderful. So when we have a question that has brackets, we get rid of the brackets by distributing in, and then we solve like a basic question. So we look at D, we're going to do the same thing. I have brackets. We're going to get rid of those brackets by distributing the negative 2 in. Negative 2 times 3 becomes negative 6n. And then negative 2 times negative 7 becomes plus 14. And a negative becomes a positive. That's a big mistake we've talked about many times, is that people forget that's a negative 2 coming in. And it still equals 56. Now that I've gotten rid of the brackets, I can focus on solving. So I'm going to move the 14 over. That leaves me with negative 6n equals 42. Now I need to get rid of that negative 6. That is a negative 6 times n because there's nothing in between the coefficient and the variable. There's nothing in between the 6 and the n. That means it's being multiplied. So we're going to divide both sides by negative 6. When I do that, I'm going to reorganize. On the left side, I have n. On the right side, 42 divided by negative 6 is going to be negative because positive divided by negative is negative. And then 7. So n equals 7 is my answer. Doing fantastic. We're going to look at E. So if we look at E, we have another unique situation. This unique situation is that on the left side of the equal sign, we have some like terms. We have a 6n and a negative 9n. We also have a plus 9 and a minus 2. To be able to solve this question, kind of like how we multiplied in these ones, I'm going to have to collect like terms in these ones before I can actually start solving. So I look at that, I recognize, oh, there's multiple n's here. I need to collect those together. 6n minus 9n becomes negative 3n's. And then plus 9 minus 2 becomes plus 7. And that equals 37. Now that I've collected my like terms, this goes back to being kind of a standard question. So to solve this, I need to get n by itself. I move additions or subtractions first, right? I'm doing BEDMAS backwards. So this plus 7 needs to move by doing the opposite operation, which means subtracting 7 from both sides. I then reorganize my work. I have negative 3n on the left. On the right, I have 30. I then am going to divide both sides by negative 3. On the left-hand side, they cancel out. I'm left with n equals negative 10. Wonderful. If we look at F, we got kind of the same situation here. So I'm going to collect like terms first. I have 6y and negative 1y. Remember, there's an invisible 1 there. So 6 minus 1y would become 5y. I then have two constants right here that are like terms. Negative 18 minus 20 becomes negative 38. And then on the right-hand side, I still just have 92. There is nothing on the right-hand side to collect like terms. I then solve this by isolating y, so I'm going to add 38 to both sides. 38, not 36. Those will cancel out. What I do to one side, I have to do to the other. So I now reorganize. I have 5y on the left equals 130 on the right. I then can divide my 5 from both sides. When I do it to one side, I do it to the other. So I divide both sides by 5. I get y equals 26. That's my answer. Awesome. Let's flip over to the next page. If we look at G here, first thing I notice about G is that there's brackets. Brackets make solving hard. So what we're going to do is we're going to get rid of those brackets. The way we get rid of brackets is we multiply whatever's right in front of the bracket. In this case, it's a 4. We multiply it into the bracket. We call that distribution. So I'm distributing that 4 in. That makes it 8n, because 4 times 2 is 8, plus 4 times 5 is 20. And then the minus 8 is still there, equals 36. After I multiplied, I ended up now having like terms. So I can actually combine those like terms. I now have 8n plus 12 equals 36. So in this case, I had to multiply to get rid of the brackets, and then I had like terms. It's like a mixture of the two questions above, right? So if we look at C, C had to multiply in. If I look at E, E had like terms. Now I had to multiply, then collect like terms. And then I focus on solving just like I always would. I want to get n by itself. To do that, I have to move the 12. The opposite of plus 12 is minus 12. That leaves me with 8n on the left, 24 on the right. I then have to get rid of the 8. That's 8 times n. The opposite of 8 times would be divide. So I divide both sides by 8. That gives me n equals 3, which is my solution. Wonderful. If we look at H, first thing I notice about H is that there's brackets. I want to get rid of those brackets by multiplying the 2 into the brackets. The 9n out front is still out front, right? Nothing changed with that. When I multiply the 2 in, plus 2 times 5 becomes plus 10. Then I multiply the 2 in, plus 2 times negative 3 becomes negative 6n. And it still equals 28. Again, after I multiplied, I ended up with like terms. So I need to collect those like terms before I can start solving. 9n minus 6n is 3n, plus 10 equals 28. I now want to solve to try to get n by itself. I'm going to have to move the plus 10 first. The opposite of plus 10 is minus 10. What I do to one side, I do to the other. I then reorganize my work. So I have 3n equals 18. I now need to move the 3 to the other side. That is 3 times n. The opposite operation of times is divide. So I divide both sides by 3. Leaves me with n equals 6. Okay. I. So if we look at I have a set of brackets there. The way we get rid of the brackets is by multiplying whatever is in front of the brackets into the brackets. This one's tricky. So if you remember back in Unit 5, we ran into this a few times. There's an invisible number in front of those brackets. That invisible number is a 1. And in this case, it's not just a 1, it's actually a negative 1. So I need to multiply that negative 1 into the brackets to get rid of them. Multiplying a negative 1 essentially just changes the symbol inside the bracket. So when I multiply negative 1 in, negative 1 times 4 is negative 4n. Negative 1 times 8 becomes negative 8. The plus 2n is unaffected because it was not inside the brackets, right? We only multiply what's into the brackets. After I multiply brackets, I collect like terms. I have a few like terms here. I have n's, which are like terms. I also have constants, which are like terms. So I'm going to add the 7 and the negative 8 to become negative 1. I'm going to add the negative 4n plus 2n to become negative 2n equals 13. Fantastic. Now I need to try to solve for n. To solve for n, I have to move things to the other side. The first thing I have to move is any additions or subtractions. This is a negative 1 that is being subtracted with the 2n. So I need to move that first. The opposite of negative 1 would be plus 1. So I need to add 1 to both sides. That leaves me with negative 2n equals 14. Remember that this negative symbol right here is still attached to the 2. It's not gone. I now have to get rid of that negative 2. The opposite of negative 2 times n would be dividing by negative 2. So I divide both sides by negative 2, giving me n equals negative 7. Awesome. J. J is unique in that it has 2 sets of brackets. That just means I'm going to have to do 2 different multiplications. So the first multiplication will be this 5 coming into the brackets. 5 times 4 will give me 20. 5 times 2 will give me plus 10n. The second multiplication is going to be that 4, but it's not a 4, it's a negative 4. So make sure that negative is also coming into the brackets. Negative 4 times 2 is negative 8n. Negative 4 times negative 3 is plus 12. And that equals 68. Again, after I multiply, I collect like terms. I have n's that are like terms. I have constants that are like terms. I need to combine those together. So 10n minus 8n will become 2n. 20 plus 12 becomes plus 32. And that equals 68. Awesome. Now that I've finally got rid of the brackets and collected my like terms, I can start solving. I'm going to subtract 32 from both sides because that's the opposite operation. I reorganize my work, so I have 2n equals 36. Then I divide both sides by 2. That gives me n equals 18, which is my final answer. Beautiful. A few with some fractions. Fractions always cause problems for people because people don't know what order to do things in. It kind of freaks them out. So what we're going to do is we're going to look at this and we're going to try to follow our method that we've been following, which is bed mass backwards. So when I want to solve for k, the first thing I want to move away from the k is any subtractions or additions. What's being done first here is that subtract 12. So I need to get rid of that subtract 12. I'm going to do that by adding 12. When I add 12 to both sides, it's going to cancel on the left side, and I'm going to be left with k divided by 5 equals 8. Now I can focus in on that fraction. Remember that fractions mean divide, so this is really k divided by 5. The opposite operation of dividing by 5 is multiplying by 5. So what I need to do to both sides of the equation is multiply by 5. Those 5s will be canceled out or equaling 1, and I'm left with k on the left side equals 40. And that's my solution. So as much as the fractions look intimidating, as long as you remember that they're just being divided by, it's not that big a deal. We look over here at L. We have the same situation. We have a fraction, which is a little bit scary. We have 14 plus and then 3n divided by 5 equals 44. To solve for n, we have to move additions or subtractions first. I need to deal with this plus 14. The opposite of adding 14 is subtracting 14. So I need to move that first. When I do that on the left side, it cancels out, and I now have 3n over 5 equals 30. Cool. We now have a unique situation here. We have a unique situation that we have 3 times n divided by 5, and we have to move both the 3 and the 5. You can do it in either order, right? So remember with bed mass, division and multiplication can switch spots. So you can choose to get rid of the divide by 5 first, or you can choose to get rid of the multiply by 3 first. I'm going to choose to get rid of the divide by 5 first. The opposite of divide by 5 would be multiplying by 5. So what I do to one side, I do to the other. These 5s will cancel, and I'll be left with 3n equals 150. Awesome. Now, I need to get rid of the 3. I do that by dividing both sides by 3. That leaves me with n equals 50. Wonderful. People usually do pretty good with those fractions. It's m and n that really throw people off. The reason why is it's because it's the first time that we kind of seem to go against our own rules. So the hard part here is in every other question, we said we move additions or subtractions first. So when someone looks at this and they want to solve for n, their first instinct is, well, I got to add 2 to both sides. And they try to do that. That's actually wrong. So you can't do that. The reason you can't do that is because that -2 is stuck in the numerator almost as if there's invisible brackets around it. And if we were to think of we need to do BEDMAS in reverse, the last thing we would get rid of is something that's in the brackets with our n. So we actually have to get rid of the divide by 3 first. I'll do that in blue. By getting rid of the divide by 3, that then leaves the n minus 2, the numerator, to just be by itself, and then I can deal with that numerator. It's a tricky one. So when you see a fraction where the numerator has additions or subtractions, you have to move the denominator first by multiplying it to the other side. Then I reorganize my work, so I'm left with n minus 2 equals 21. I then add 2 to both sides. That gives me an answer of n equals 23. Awesome. One more time. So if you look over here at n, we see that this is a situation where people would try to subtract 8 right away, but you can't. You have to almost imagine that numerator's in brackets, right? That numerator's like stuck together. And I can't move anything in that numerator until I get rid of that denominator. To get rid of this -2 or -2, that is a divide by -2, so I need to multiply both sides by -2. That will cancel the -2's out, and I'm now left with 4a plus 8 equals -20. And it's just kind of a standard question from there. I can move the 8 over first. That gives me 4a equals -28. And then I can divide both sides by 4. Gives me a equals, whoa, sorry, my brain's not working, 7. Awesome. That's solving multi-step equations. I'm just going to do a little extra here for a second. So just a reminder on what solving an equation means. What we've done is we have found a value for a variable that makes the original question actually balance out. So if you remember, the original question here was n minus 2 divided by 3 equals 7. And what we have said is that when n equals 23, this is actually true. It balances out. And you can do something called verifying your solution. What you do is you go to your question and you change n to be what you said it should equal. So if I look back at this question, that means I have 23 and then minus 2 and then divide by 3 equals 7. If I was to put that in my calculator, 23 minus 2, that's 21 over 3 equals 7. 21 divided by 3 is 7, so that means both sides equal 7. That's called verifying your solution. You can actually check all of your answers on your own to see if you're right by taking your answer, putting it into the original question, and seeing if both sides actually balance to be the same number. Wonderful. Enjoy your practice.